Okay, I think we're live. Good morrow, gentle people. Today we are going to be doing part two of the what's it called? Guessing game that we were doing yesterday. Today we're going to be generating the secret number, and let's just hop right into it. Let's do that. Okay, let me move this a little bit to the left so that I can see my screen. Sometimes it's difficult to read with the camera in front of it. All right, let's jump in. So now we're generating our secret number. Yesterday, what did we do? We learned how to do print line macro. We did binding a variable to an empty string for user input. We learned what the standard input output module is, and we also imported it into our current file. We also did what was this? Okay, yeah. We did an expect, which is result. If we go back from yesterday, result is going to be a success or a failed attempt. Okay, and then once it fails, it will give it either the expect, what's it called, result, which is going to be crashed, as I put there. Sometimes you could put whatever. You could put failed, did not compile, whatever you want. We also figured out how to use placeholders, and this is a great example of what a placeholder is. You could put it in the placeholder, or you could put it outside the placeholder with a comma. Go back to the previous episode, and we'll explain everything about creating this, the beginning of the guessing game. Now let's jump into what we're going to do today. Okay, we're going to actually generate this secret number. Next, we need to generate a secret number that the user will try to guess. The secret number should be different every time so that the game is fun to play more than once. We'll use a random number between 1 and 100 so the game isn't too difficult. Rust doesn't yet include random number functionality in its standard library. However, the Rust team does provide a rand crate with said functionality. We did look at the crates, crates.io yesterday, which is where people who are Rustaceans like you and me upload open source code so that we can use external crates and then import them into our projects. You could go back to the last episode. Everything's in the last episode. Okay, so let's keep going. Increasing functionality with a crate. Remember that a crate is a collection of Rust source code files. The project we've been building is a binary crate, which is an executable. The rand crate is a library crate which contains code that is intended to be used in other programs and can't be executed on its own. Cargo's coordination of external crates is where Cargo really shines. Before we can write code that uses rand, we need to modify the cargo.toml file to include rand crate as a dependency. I went back a little bit so that we can have a little bit of a refresher, but we did do this yesterday where we executed, where we implemented the rand crate, and we went through how the rand crate is, how we build it, and then it has all these other dependencies that has to compile as well. So open that file now, add the following line to the bottom beneath dependencies section header that Cargo has created for you. Be sure to specify rand exactly as we have here, with the version number or the code examples in this tutorial may not work. Okay, we're going to skip this portion because it's just going to talk about semantics. And just want to make sure. Okay, we talked about this yesterday. I went back way too far. Ensure reproducible builds. Sorry, I was on the wrong one. Generating the random number. So let's make this one instead. Let's start using rand to generate a number to guess. So the next step is to update the source.main.rs file shown on the following. Okay. So what they updated, I'm seeing this is new. Rand module was being imported. We have a secret number variable as well. Let's see. New guess is still there. Read line, expect, and print line. Okay, so everything is there. The only the difference is that we have this new module and we have this new variable. And let's see what those two things do. So first we add the line used rand : RNG. The RNG trait defines methods that random number generators implement. And this trait must be in scope for us to use those methods. Chapter 10 will cover traits in detail. Okay. Sorry, people are messaging me. Let me put this on D&D. I don't like to read messages while I'm streaming. Okay. Next, we're adding two lines in the middle. In the first line, we call rand : thread RNG function, which gives the particular random number generator we're going to use one that is local to the current thread of execution and is seeded in the operating system. Then we call gen_range method on the random number generator. This method is defined as the RNG trait that we brought into scope with the use rand RNG statement. The genRange method takes a range expression as an argument and generates a random number in the range. The kind of range expression we're using here takes from start ... end and is inclusive on the lower and upper bounds, so we need to specify one ... include or $100 to request that the number is between 1 and 100. So if we didn't have that equal sign, it'd be 1 through 99. We want to include 100 because it's only going to include the range between those numbers. Okay, interesting. Note, you won't know which traits to use and which methods and functions to call from the crate, so each crate has documentation with instructions for using it. Another neat feature of Cargo is that running cargo doc -open command will build documentation provided by all your dependencies locally and open it in your browser. What? Okay, why don't we try that? I'm currently in my projects folder, and we learned how to do this within episode 1, how to change directory into your actual project. So I have a couple of projects in my projects folder. You can see I have my Hello World, my Hello Cargo, and my guessing game. But I'm going to CD into my guessing game, and now I'm there. Okay, now I'm going to do it ls. You can see I have all my stuff there for my guessing game project. Right? ls is list, so you can list everything that's underneath that folder or within that directory. I do want to try cargo doc. I've never actually tried that, so let's do a cargo doc -- open, and let's see what that does. Do I have to specify what I mean? Oh, click rand. Oh wait, hold on. Was I supposed to click something? Let it just do its thing. It's taking a long time, like damn. Alright. Whoa. What's all this? This is interesting. So another new feature, doc-s open command will build documentation provided with all your dependencies locally. Open it in your browser if you're interested in any other functionality in the RAND crate. For example, click RAND on what I did. Oh, okay, so this is RAND G. Whoa, okay. This is getting crazy. What? I thought it was just gonna open up in my browser. I guess not. I guess we can go more in depth on this later, because I'm a little bit confused. Maybe that's just me issue. Maybe everyone else can do it except me. Anyway, whatever. Let's keep going. Alright. The second new line prints a secret number. So let's get back to what we were doing. Let's go back here. I'm just gonna move this so that I have more space. Okay, the second new line prints a secret number. This is useful while we're developing the program to be able to test it, but we'll delete it from the final version. It is not much of a game if the program prints the answer as soon as it starts. Okay, yeah, that makes sense. Okay, let's go and implement these two things. So we're going to use rand RNG. Perfect. And then we also implement this let secret number. We do it right underneath this. Rand thread RNG gen range. And then we're doing including 100. What's our range? Now, maybe it's just me. When I read things and I don't really understand, like over here when they were talking about rand and RNG, which is, I guess, the range, I like to reread them so that I do understand it. Or, even better, I like to look up documentation. So maybe we should do a little documentation lookup for rand. So I'm just going to do rand rust docs. I just want to see what they have there. I just like to look. Create rand. Sometimes they have some good stuff. So we're doing this, fill any type with random data. Okay. So that thread rand, or range, sorry, the thread range is fill any type implementing fill with random data. Okay. And then I also want to look at, oh wait, no, this is thread rand. Okay, it's going from random. Generate a random value with a thread local random number generator. Okay. Interesting. And then there's another one. access a fast pre-initialized generator. Also gen, not here. Maybe we could like ran gen. Gen range. Doesn't like it. Okay, in Rust, the gen range method from ran crate is used to generate random numbers within a specific range. Okay. Used to generate random numbers within a specific range, and then we put our range in it, which is 1 through 100, including 100. And thread range is just generating a pre-configured random generator. So, nice. Okay. Anything else? Let's see. Anything else that we may have missed? I'm just going to put this in another line. Let's clean it up. Sorry. Today has been a weird day, and I'm sorry if this is not as entertaining. It is because I'm having a weird morning. And sometimes we just have one of those days. We're gonna do a cargo build. Oh, it's because I have a secret num. Okay, so let's read. Let's go back to my terminal. Let's put that up. All right. So unused variable. What did they use? Let's see. They haven't even used secret number yet. So, oh, they have. Oh, they have. Oh my goodness, we missed a whole line. Print line secret number is secret number. My bad. We're gonna do another print line. The secret number is our placeholders, and you can put them in the curly braces or do a little comma situation and just put our secret num. Better. Okay. Perfect. Let's do, what did they say? Let's just cargo run. Cargo run. Okay, guess the number. The secret number is 90. Please input your guess. My guess is 90. What? I think we put it in the wrong order. Yeah, so it's like that on here as well, but I'm positive we're going to be switching around so that we input our guess before it provides us our secret number. You know what I mean? Anywho, the second line prints the secret number. This is useful. We're developing the program. We're able to test it, but we'll delete it in the final version. So they're like letting us know. It's not much of a game if the program prints the answer too soon as it starts. Yeah, doesn't make any sense. What are we playing? Huh? Anyway, we do our cargo run. You should get different random numbers. Yeah, so we can do another cargo run. We got 9. 9. We do another cargo run, 33. So we're getting all numbers ranging from 1 to 100, including 100. Okay. All right, let's just clear that for now. We don't need that. Everything away, and we'll just put this down. Okay, comparing the guess to the secret number. Okay, now that we have user input and a random number, we can compare them. The step is shown in 2-4. Note that this code won't compile just yet, as we'll explain. So we have another imported module. There's another standard input, CMP ordering. Don't know what that does, but we'll see. And it seems like we have a match sequence. We've never done matches before, so this is a little bit new. We have a less, greater, and equal. That's new. All right. First, we'll add a use statement, bring the type std, CMP, ordering into scope from the standard library. The ordering type is another enum that has the variance less, greater, and equal. These are three outcomes that are possible when you're comparing two values. Okay. We want our guests to, we want the terminal to keep prompting us until we get our guess. Essentially what we're doing now. So if it's too high, we want it to tell us our guess is too high. If it's too low, we want to tell us our guess is too low. If it's correct, it needs to be the same number, and it's going to tell us you got it correct. So, all right. Then we add 5 new lines at the bottom that we're using the ordering type. The CMP method compares two values that can be called on anything that can be compared. Then it takes a reference to whatever you want to compare it with. Here is comparing guess to secret number. Okay, which is correct because the secret number, the guess is our guess, and the secret number is going to be the secret number that it randomly generates. So it should be equal to or greater than or less than, and then it needs to tell us that. Then it returns a variant of the ordering enum we brought into scope with the use statement. We use a match expression to decide what to do next based on which variant of ordering was returned when they call CMP the values in guess and secret. So match expressions are very, very useful when you want the exact expression. The thing is, we're going to be going into depth on match expressions within the later chapters because this is only chapter 2. But I think this is only a Rust only thing, which is pretty cool. There's a lot of things in Rust that are Rust only, but think of match as kind of like a let statement, but you would have to use all possibilities, essentially. Okay. Okay, a match expression is made up of arms. An arm consists of a pattern to match against. And then the code that should be run if the value given to match fits the arm pattern. Okay. Rust then takes a value given to the match and looks through each arm pattern in turn. Patterns in the match construct are powerful Rust features. They let you express a variety of situations your code might encounter, and they make sure that you can handle all of them. These features are covered in detail in Chapter 6 and Chapter 19, respectively. Let's walk through an example with the match expression we use here. Say that the user has guessed 50 and randomly generated secret number this time is 38. When the code compares 50 to 38, the CMP method will return ordering greater because 50 is greater than 38. The match expression gets the ordering greater value and starts checking each arm pattern. It looks at the first arm pattern, ordering equals : less, and sees that the value ordering : greater doesn't match ordering : less. So it ignores the code in that arm and moves to the next arm. The next arm pattern is ordering : greater, which does match ordering : greater. The associated code in the arm will execute a print too big to the screen, and the match expression ends after the first successful match. So it won't look at the last arm in this scenario. If you have ever coded in any other language, an easy example would be Python. They have let expressions. So it is an order of operation type of expression. When you're going through a let expression, not a let expression, what am I saying? What is that? Is it let expression? Why am I thinking let? Order of operations expression in Python. Why am I not remembering what it's called? Oh, if expressions. Okay. If else or else if expressions. Why am I saying what? Okay, so in those type of operations, you're going from the first, if this does not equal this, then this will happen. Else this would happen. Else that will happen. Okay? So in those expressions, it's going to be order of operations. It's going to go through the first else if expression and see if it's correct or not. Then if it isn't, it's going to the next if else expression. And if it is correct on the next one, it won't look at any other else if expressions. It will go straight to exiting the program or whatever result is supposed to happen. It's going to return something, let's say, be like you won the game or whatever. Anyway, it's in the same way as a match expression because it's only going to go within the order of operations. So if you have a smaller number, it probably is going to go first. That's why it says it's going to be less, then it's going to be greater, then it's going to be equal. Because you don't want it having the greater than order of operations first. Because you want to make sure you cover all of your bases before you get to that point. Okay? Either it will panic or it will just give you the wrong or incorrect result, which you don't want. Okay. Okay. Let's finish reading this and then we'll implement what's going on here. Today I'm just so tired. I'm so sorry. I want to be in very high spirits for this video. I'm just very exhausted this morning or afternoon. I think I just haven't eaten a lot, so I need to eat something after this. Let me see. I want to be consistent in how long these videos are. I want them to be like around an hour max. Some of these videos are not going to be an hour. Like some of them are going to be more than an hour, and that's just how long the chapters are. If anything, I'll make 2-parters for those chapters that are like extensively long, like really long. Like one of these, which is like a whole project. You know what I mean? Okay. The core of the error states that the mismatch types. Okay, so this is, let's see. We try to compile. Let's look at this before we jump into that. You try to do a cargo build. Source/main. match guess.cmp, and then we reference our secret number. Expected a string found an integer. Okay. Expected reference string found reference integer. Method defined here, blah, blah, blah. Okay, so we have an error. The core of the error states that there are mismatched types. Rust is a strong static type system. However, it also has a type inference. When we wrote let mute guess string ... new or : new, Rust was able to infer that the guess should be a string and didn't make us write the type. Now, the secret number, on the other hand, is a number type or integer. A few of Rust number types can be a value between 1 and 100, I32, and a 32-bit number. U32 is an unsigned 32-bit number. I64 is integer. I means integer. A 64-bit number, as well as others. Unless otherwise specified, Rust defaults to an I32, which is a type of secret number, unless you add the type information elsewhere that would cause Rust to infer a different numerical type. The reason for this error is that Rust cannot compare a string and a type number or number type. Ultimately, we want to convert the string the program reads as input into the number type so that we can compare it numerically in the secret number. We do so by adding this line to the main function body. Okay. So essentially, the compiler is getting confused because we have named the secret number, or the number that we are guessing, as a string. And Rust is very strict on what type of integer or what type of string that we're going to be using. So we need to use types. And I think they're going to show us in the next one how to type it. Yep. Okay, so you can see here, we have a let guess equal an unsigned integer, which is 32-bit. So we're typing our variables so that it knows next time when it's compiling and it has an integer instead of a string, it's not going to panic, freak out, and say it's incorrect, that we're using incorrect types. Okay, so let's write all of this in. We just did a really fast crash course on match, which we're going to be writing here. We did also how to type our variables. And it's going to go into detail on how we're using the trem, parse, expect, which expect we did learn yesterday, which is a result, and expect is an error. Okay, and that's what the error should show within a compiler or terminal, essentially. All right, let's put this in. So let's go back to the top. I'm pretty sure we have to put our ordering. We're going to use standard CMP ordering. Then we also put this guess. Right, okay, underneath our guess, we're going to put our match statement. So we're matching our guess to our secret number that we're referencing here, secret num. Then we're doing our order of operations, which we're going to start with our lowest remember, it's going to go through each line, and if it doesn't find it on that line, or if it says, oh, this is greater or equal to, on the first couple of lines, it's never going to give you the correct number. So you have to do it in order of operation. So it's going to be smallest to largest. You always do that, especially with any if-else expressions, because there are if-else expressions in this as well. Match statements, anything that has to do with that. So ordering is going to be less, and then we're going to do a print line. Too small, comma, make sure you put the comma there. Ordering greater, print line too big. And then lastly, ordering equal. And then print line just right. Let's see. You win. Or I'm just gonna put winner, chicken dinner. There you go. I always, and you don't have to do this, you don't have to put a comma on the last line, it doesn't really matter, but I always put a comma just in case I need to add something after that. You never know. You never know when you need it. Right. Let's go back. Oh, and we're gonna do a little save. Okay. And then we need to use this type. So we're going to go back to our let expression. Let guess, and I'm not sure why. Oh, wait. Here, we put a different let expression. Okay, so they're adding a new let expression. My bad. I'm thinking that they're changing the previous let expression. Okay. Don't listen to me. I don't know anything. Okay, this is getting a little bit discombobulated because we are adding a lot of stuff and we're adding it all randomly. And that's the thing about the book. I know they're trying to teach us what we need to add, how we need to do it, but there's a specific way to organize your code so you don't get confused. And this chapter doesn't do a really good job of it, unfortunately. So I'm pretty sure we are deleting this print line secret number right now. So we have this let secret num. Please input your guess. And think of it as when you're going through the steps. So it has to generate a secret number first. That's perfect. Then it's prompting us, please input your guess within the terminal. Perfect. Then we're able to bind that string that we created, or that's a new string that's created and binded to guess. So it's going to hold whatever information that we put in terminal in guess. Perfect. Then it's going to read our guess. If it crashes, it's going to say crash. Okay? This print line, you guess this guess. I guess I can stay. Then we're doing our match. Okay. I guess this is above. So let we're doing another guess. We're doing another let guess. But I don't like that they have the same variable name. You know what I'm saying? Why is this going on? I don't like that they have the same variable name. So we can change it to let user guess. It just gives it a little bit more variety. Also don't love that they set it up this way. I like to see everything in full, the whole code together. It's whatever. We're learning, they're learning, everyone's learning. So we're using guess.trim, which is our guess, parse, and then we're going to use our expect, which we know what expect is. We're going to learn about trim. Oops. Sorry, I'm not looking. Expect. Also, still have long nails. What's wrong with me? I think I'm just gonna get them done, and maybe that will help. Because I do cut them really, really short for the most part, but they're really grown out right now. So I'm sorry. Just gonna have really bad typing skills at the moment. Usually I'm much better, I promise. Okay, you guess this guess. Then we have our match statement. Everything looks pretty good. Okay, so we create a variable named guess, which is now our variable user guess. Okay, it's just easier. Okay, we created a variable named guess, but wait, doesn't the program already have a variable named guess? Yes, it does. It does, but helpfully Rust allows us to shadow the previous value of guess with the new one. Shadowing lets us reuse guess variable name rather than forcing us to create two unique variables, such as guess string and guess, for example. We'll cover this in more detail in chapter 3, but for now, know that the feature is often used when we want to convert a value from one type to another. Oh! Okay, I'm going to take back what I said, because we are converting a type to another, which is guess is a string, then we're converting it to an integer. So we do need to shadow it. Okay, we bind this new variable to the expression guess.trim.parse. The guess in the expression refers to the original guess variable that contained the input as string. The trim method on the string instance will eliminate any white space at the beginning and at the end, which we must do before we convert a string to an integer or unsigned 32-bit integer, which can only contain numerical data. The user must press enter to satisfy read line and input their guess, which adds a new line character in the string. For example, if the user types 5 and presses enter, guess looks like this, 5/n. The /n represents a new line. On Windows, pressing enter results in a carriage return in a new line. Okay, /r/n. The trim method eliminates the /n or /r/n, resulting in just 5. Okay, so we don't have to put a /n. The parse method on strings converts a string to another type. Now this is what we needed because it was a string type. Now we need to change it to an integer type. Here we use to convert from a string to a number. We need to tell Rust the exact number we want to be using. Let guess U32, which is our unsigned 32-bit. The colon after guess tells Rust we annotate the variable's type. Rust has a few built-in number types, the U32, seen here as an unsigned 32-bit integer, it's a good default choice for a small positive number, which we're only going to 100. We don't need an unsigned 64-bit. It's just unnecessary, you know what I mean? And you can look up what those numbers go to, what the 32-bit goes to, what's the highest number for that. Woo, sleepy. All right, let's get through this. We're almost done. Okay, additionally, the U32 annotation in this example program and the comparison with the secret number means Rust will infer that secret number should be U32 as well. So now the comparison will be between two values of the same type. Okay, the parse method will only work on characters that can logically be converted into numbers and so can easily cause errors. Or if, for example, the string contained a thumbs up emoji, and a % sign, there will be no way to convert that to a number. And I'm pretty sure UTF-8 numbers or integers or whatever, I think we are able to use emojis. It has so many different characters in there. I think it has many different language characters as well, like Chinese characters or Mandarin. I'm not positive. I'm not well versed on that. But I'm positive they go into it in the next chapter when we're talking about characters. And you'll see that there are emojis that you can use within Rust. And you can actually compile and see in your terminal little Rust station if you want. You know, emojis. I think that's cute. There will be no way to convert that number. Okay, so because it might fail, the parse method returns a result type. Remember, we're talking about result types, much as readline method does. Okay, so remember when we're doing result types, and you can see in our previous one where we do a readline dot expect, which is a result type of an error. Okay, if parse returns an error result variant because it cannot create a number from a string, the expect call will crash the game and print the message we give it. That's exactly what we did over here in, why am I pointing? Over here where we did our standard input output and we did an expect and we expected it to crash. So, all right, we'll call crash. If parse can successfully convert the string to a number, it will return the OK of variant, and expect will return the number that we want from the OK value. Easy enough, simple enough. This is so simple. Super simple. Get with the program. A lot of repetition when learning these things. A lot of projects. And you'll see this in your next projects. We'll be using a lot of these concepts over and over and over and over again. And repetition is the best method, okay? Okay, so we're gonna do a cargo run. Let's do a cargo run. Let's see what it says. If we get any. Okay, so guess the number. Please input your guess. I'm gonna guess, because my favorite number is 9. Too small. So now we're gonna get into game loops, and let's talk about this. So nice. We've even though spaces were added before the guess, the program still figured out that the user guessed 76. And run the program a few times to verify that different behavior with different kinds of input. Guess that the number is correct. Guess the number correctly. Guess the number is too high. Guess the number is too low, etc., etc. Okay. We have most of the game working now, but we have this last bit. But the user can only make one guess, and that's our biggest issue at this point. Let's change that by adding a loop. And we're going to be talking about loops, while loops, for loops, all that fun stuff very, very soon. But right now, we're just going to be going to loops. So let's just try a couple of them. I'm going to do another cargo run. Pull this up a little bit so everyone can see. Okay, I'm going to do like 80. Oh, too big. Alright. Then we'll run again. And I'm going to do like 50. Too big. Still. Let's do 1. Too small. Okay, so it's working just as fine. I'm not sure what the secret number is because it's randomly generated, and every single time you do a cargo run, it changes. So we never have gotten the secret number yet. But we can actually do a little, and I know we haven't done this yet because we haven't gotten to multiple guessing and the loop and whatever. Let's do a CLS. We can actually just see what the random generated guess is because it is binded to, oops, I spelled print line wrong. Secret number. So I just want to, this is just a test. We're going to take this off after. But if you are having trouble and you really do want to see the secret guess and see if it's correct, and this is another way of testing it. So we're running it, putting my secret guess, I'm putting 6C. The secret guess was actually 98. So that's correct, that it was smaller. Because it wasn't showing me what the secret number was, I'm kind of just guessing and thinking, is this match sequence actually working or not? You know, that now I can confirm that this is actually working. So I'm gonna do like 15. Too small. That's correct, isn't it? Okay. So now I know it's working. I'm just going to, we can comment this out actually. Perfect. And we're gonna keep going. So okay. Allowing multiple guesses with looping. The loop keyword creates an infinite loop. We'll add a loop to give users more chances at guessing the number. So were we supposed to do a print line secret number? Maybe we were. I didn't see it here. I just want to know if I missed it. Oh, we took it out. The thing is, we took it out because we were supposed to take it out. We weren't supposed to leave it in. Alright. So the loop keyword creates an infinite loop. We'll add the loop to give users more chances. And as you can see, we moved everything from our guess input prompt onward into a loop. I'm not positive why they still have the secret number is blank above our guess. Maybe that's just a little, that annoys me a little bit. I know we're learning and everything like that, but I don't think it should be there. I think I need to take it out now because we're doing looping. At least let it be at the end. You know what I mean? I don't understand why it's in the beginning. As you can see, we've moved everything in the guest prompt onward to the loop. Be sure that the indent the lines inside the loop another 4 spaces each and run the program again. The program will now ask another guess forever, which actually introduces a new problem. It doesn't seem like the user can quit. And there's different types of loops. There's for loops. This one has regular loop. There's for loop. And then there's also while loop. So I guess we're learning about loops right now. It doesn't seem like the user can quit. So within a loop, it's going to keep going and keep going and keep going and keep going. And if you don't have a specific way to exit in your program, it will never stop. And you would have to do like a Control-C to stop it to exit it. You know what I'm saying? So the user can always interrupt the program by using keyboard Control-C. Well, I'm ahead of it. But there's another way to escape this insatiable monster. As mentioned in the parse discussion, in comparing the guess of the secret number, if the user enters a non-number answer, the program will crash. We can take advantage of that to allow the user to quit, as shown here. So this is interesting. They want us to use a string or string characters instead of an integer to crash our program. Don't think that's the best way to stop a program. I think you can implement an exit plan within your code. But I'm positive we're going to do that first. Okay, typing quit will quit the game, but as you'll notice, so will entering another non-number input. This is suboptimal to say the least. I cannot speak. This is suboptimal to say the least. We want the game to also stop when the correct number is guessed. So, quitting after the correct guess. Okay. Let's program. Oh my goodness. Oh my god. We're literally at the end and I can't speak. Let me take a sip of water. Whew. The session is difficult. We're almost done. Alright. Quitting after a correct guess. So let's program the game to quit after the user wins by adding a break statement. And that's another thing. That's how you stop within your code. Alright. Adding the break line after you win makes the program exit the loop. When the user guesses the secret number correctly, exiting the loop also means exiting the program because the loop is the last part of the main. Okay. So let's implement this loop. Let's go back up. We have this loop right here. And it starts right here. Let me see the best way to do this. Sometimes it's easier. Oh, my bad. Nice. Okay. Just making sure that all of my curly brackets are correct. I think they said 4. 1, 2, 3. 1, 2, 3. Is that fine? I think it's correct. This should be all on one. Print line. Yeah. No, that's correct. It looks correct to me. Anyway. Who am I supposed to say? Alright. And then we do a break statement. Make sure that's after the loop, and just make sure that this is the correct one. Yeah. So the break is usually, is it put in the loop or after? I guess I put it right underneath it. So they want to break after you win. I think you can put it after the loop as well, but you know what? Oh, I guess, oh, okay, I see what they're doing. I see what they're doing. They want to break after you win. So they're putting this with that. Okay. Me literally like, I'm like, what the hell is going on? Oh, I'm sorry. I just didn't understand what it was trying to do, okay? Just me being slow today, like, my brain is not working like it should, as usual. Okay, so that is for that specific, so it wants to break the loop once you get it correct. So once you get it correct, you're gonna get that winner, and then it exits the program. Okay, that makes more sense. In my head, I was like, what? What are they doing? All right, handling invalid input. To further refine the game's behavior, rather than crashing the program when the user input is non-number, let's make the game ignore a non-number so that the user can continue guessing. We can do that by altering the line where guess is converted to a string, from a string to a U32, as shown in the listing below. So let's go back when we go to parse. And for our expect, we're actually just going to take out our whole expect, like so. And we're going to do a result. So if our number equals number, and where are they getting this num from? That's my question. Interesting. Let's just go with it for a bit. Oh. What? Okay, I'm sorry. I was like, am I doing the wrong one? No, but I'm doing the correct one. Okay. So, and then error is whatever. This is kind of like a placeholder, and it means anything else than what the number is. Continue. Sometimes I get confused when they put in parameters that I've never seen before. How does that know that this is number? That this is a secret number? Do you know what I mean? So let me see if it says anything about it before I change it myself, because I do change stuff that make them more, just it helps me with understanding. Okay, we switch from expect call to the match expression to move from crashing on an error to handling an error. Okay, Remember that parse returns a result type, and result is an enum that has the variance OK and error. Yep, so we're creating a new result type within that let guess, the variable guess. We're using the match expression here as we do the ordering result with the CMP method. Okay, so if parse is able to successfully turn the string into a number, it will return the OK value that contains the resultant number. What? Yep, that's correct. And then the OK value will match on the first arms pattern, and the match expression will return the number value that parse produced to put inside OK. My question is, why is it named num? Okay, how does it know that num is actually the the correct guess? You know what I'm saying? Anyway, you know what I'm saying? You picking up what I'm putting down? The number will end up right where we want it in the new guess variable we're creating. If parse is not able to turn the string into a number, it will return the error value that contains more information about the error. The error value does not match the OKNum pattern in the first match arm, but it does match the error pattern in the second. Oh. Wait, what? Let's read that again. Okay. If parse is not able to turn the string into a number, it will return error value that contains more information about the error. The error value does not match the OKNum pattern in the first match arm, but it does match the error pattern in the second arm. Okay. The underscore is a catch-all value. In this example, we're saying we want to match all error values no matter what information they have inside them, so that the program will execute the second arm's code continue, which tells the program to go into the next iteration of the loop and ask for another guess. So effectively, the program ignores all errors that parse might encounter. Okay. Now everything in the program should work as expected. Let's try it. I'm going to put this back in. Oh, I guess not. Because like if you get the secret number, you should know it at that point. Okay, it's giving us the whole breakdown of the code. Let's try it. Let's give it a try. See if it runs. Did I miss something? Expected one of. No. What I do? To parse. Something else. What does it expect? Sugar plum. What do you expect? This is why I was confused. Now we have to figure this out because they don't. Sometimes people just don't be telling what's going on. What is this? Okay. Oh, expected. So is it expecting an expect? Now I'm wondering. Oh, I know what I did wrong. It's a match statement. So we have to put match in front of it. Oh, that's why I was so confused. I was like, how does it know? How does it know we're supposed to be matching? Anyway, let's keep it. I'm like, why are we putting none there? Let's try it again. Oh, it worked. Let's do 20. Too small. 60. Too big. 50. Too big. 40. Too small. Okay, so it's 45. Too big. 42. Ah! Yeah, she's a winner. She's a winner. Okay, so now you're guessing each of work. Okay, at this point, you've successfully built the guessing game. Okay, congratulations. This project was a hands-on way to introduce you to more Rust concepts, let match functions, the use of external crates. In the next few chapters, we'll be learning about the concepts in more detail. So chapter 3 covers the concepts that most programming languages have, such as variables, data types, functions. It's more basics, and it shows how to use them in Rust. Chapter 4 explores ownership, a feature that makes Rust different from other languages. Chapter 5 discusses structs and method syntax, and Chapter 6 explains how enums work. So tomorrow we will be going into common programming concepts, and that is chapter 3. I hope that this video was pretty informative. There are times where I'm challenged when going through even simple problems, and I'm like, wait a minute, this is being explained to me, and I'm not catching on, like I'm not getting it. And I think that's okay. Here, let me change to a larger scene so you can see me when I'm speaking. I think that's okay when you're having issues, even learning new concepts or relearning old concepts, and you have like a bit of an issue and you can't get over that hump, and you're like, how do I troubleshoot this? It's perfectly fine. That's how you go. That's how you learn. I think this video was very informative. I'm sorry that I'm not very I don't have like a lot of energy today. And I keep tripping over my words. It's just one of those days, and I apologize for that. But I hope that you come to the next video. I think I'm actually going to start doing this at 12 p.m. 12 p.m. or 1 p.m. And I'll put that in my bio so that everyone who wants to join is able to. I do want to do Tuesday through Friday. I think Tuesday through Fridays is a very good time for me because no one is at my house during those times. So yeah, I will see you in the next video. I hope you have a wonderful day, and yeah, join me for tomorrow's video, streaming, whatever.